Hi, I'm Nathan, and today I'm going to be taking you through a STAR-CCM tutorial on how to do the flow past an object. Specifically in this video, I'm going to be showing you how to do the flow past a simplified bullet, which I'm going to generate through creating a cylinder and uniting this with a sphere on the top. But this tutorial is actually generalized to the flow past any object, as long as you can draw the object you would like to do the flow past in CAD, and then create a cuboidal domain around it, and then you can use this same tutorial to do the flow past any object. So I'm starting by drawing a circle. This is a circle with diameter 5 millimeters, which represents a bullet of diameter 5 millimeters. And then these points I'm drawing here are just the limits of this square domain. So I would like the domain to be 1000 by 1000, while the object we're doing the flow past is just 5 meters in diameter, and this gives us plenty of space. So then we're just extruding this circle to get a cylinder. So then we want this sphere to be centered on the top of this cylinder, so that's why I've chose ZX equals 10, and as you can see there's a little circle on the top of the cylinder, and we'd also like the diameter to be 5, so it's the same diameter as the cylinder. As you can see, it's joined it together, with the one thing to note being that I used the unite there, so it united the cylinder and the sphere. And then we'd like a cuboidal domain, so gonna extrude it symmetrically the same as the width. And then we're just doing one minus the other, so we're taking away that bullet from the cube. So then you're going to want to open up STAR-CCM. You want to import the CAD that we've just drawn on NX. As I said before, you can draw on STAR-CCM, but I much prefer to draw on NX, and you can draw on whichever software you're most used to. So we've created a new geometry part. You'd like to see it. This is the part. And then you want to check that your object, in my case this bullet, is in the middle, and I've just taken a plane section here, and if we zoom in, there you go, you can see that it has been subtracted from this cube. Then we want to split the surface up. As you can see here, we've got 9 different surfaces, with 6 of them being the cube and then 3 of them being this bullet surface. So the inlet is at the top, and that's because the bullet has the top at the top in Z, so we would like it to flow past it as opposed to flowing left to right, which you could also model, but that's not what we're interested in. And then assign parts to regions and each part surface. So you want a boundary for each part surface so that we can apply different conditions to different boundary surfaces. So we've got the inlet at the top, which we'd like to be an inlet, outlet at the bottom, the bullet is a solid, and then the left, right, front and back we would like to be symmetry planes. Now we'd like to generate a mesh. Just going to use the automated mesh. I'm going to use polyhedral elements here. And we'd also like a prism layer to better capture the flow at the surface of the bullet. So you could play with the options on the mesh here. If you want a better result, I picked a base size of 0.05 just so that it converged in a reasonable amount of time. But if you wanted a more accurate result, you could select a smaller base size and have a finer mesh. And the core mesh optimization here is how good would you like the elements to be. So then we're executing the mesher. This took a little while, but I've actually just skipped the waiting because I don't want you to wait. But if you're running this on your own computer, you'll have to wait while the mesh generates. And there we go, that's the cross section of the mesh. And you can see there's the bullet in the center. Then we're going to want to select some physics. You can play with the physics. So here I've just selected it to be a gas, an ideal gas. And we've got no temperature effects, which is unrealistic for a bullet, but this causes it to converge within a reasonable amount of time and with a reasonably coarse mesh. And if you see here, the velocity is negative because the top surface is at the top in Z, and we would like it to flow from the top to the bottom. So and then initialize the solution with the green and then run. This also took a while, so I'm skipping the waiting, but if you're running this for yourself, fortunately you're going to have to wait. And then here we just want to plot the results. So I'm interested in plotting the pressure and also the velocity vectors, so that's what I'm going to do here. First we're going to plot the velocity vectors in this mid-plane past the bullet. So if you notice here, the arrows are actually too large to be able to see what's going on, so we can change the relative length of these vectors. And now you can see the velocity vectors going past the bullet, which I think is quite cool. And you can see there's a slight recirculation at the back of the bullet. Pressure. There we go, you can see an area of high pressure just in front of the bullet, and you can see some low pressure just behind. So I hope this has been helpful. Thank you for watching.